Electrical and Electronics Engineering from where Sri Rangarajan Shakuntala College of Multimedia, Chennai during 2003 to 2007.
Lecture झाला.
Yeah,
एक
and
तासानंतर.
he's almost have 8 years of experience, 18.5 experience. Presently, is working as a maintenance head of the department in the organization of SJS Enterprises, which is a listed company. And today he takes the and now invite Mr. Sridhar to take the session on. Thank you all.
Sridhar sir, are you?
Add કરું છું આમાં ક્રિએટ કરી
this session.
મારું પોતાનું બીજું બારોટ સાઈડ ને પૂછીએ કે સર આપ મને પૂછ્યા વગર તમે
કોન્ટેક્ટમાં ભાઈ એવું ન થાય કે આપણે ઠીક છે સર.
Okay, shall we proceed now?
Yes sir, yes sir. Should we share from here sir? PPT we will share.
Good morning everyone. I'd like to take you all to the AI in digital manufacturing and industry automation. And interactive session, you can stop me wherever you want and I can explain to the best of my knowledge. And if anything related to queries and question and answers, let us keep it in a final session. And I like to take you into the sessions now. Now, AI is machine intelligence in automation. What is AI? AI is nothing but the artificial intelligence, right? Artificial intelligence is nothing but concepts of you should be strong in the concept of 3D printing as well. And I'll take up in the separate interactive session that what are the advantages 3D printers and digital print, right? From the beginning, I'm saying it's an interactive session, not like that I'm just throwing out whatever I know. It's like you can interact so that we can so that the one among the others will get clarified, the other will have some other doubts. They can start interacting. Okay, I'll move forward further. So you got about 3D printing, right? 3D printing is advantages, digital print advantages. We can see the job without having the job in hand. And also performance and stress analysis also you can make printing software. That is RP software, rapid prototyping software. Before slicing, it will analyze like analysis and Fusion 360 and all. You might have heard about it. Since you are from the mechanical engineering, you might be strong also on that. So that it will have an analysis whether the product will stand. One interesting examples I like to know, I like to clarify with the 3D printer. You all know about that aircraft, right? Aircraft, that engine manufacturing, everything. Now everything is concerned more about reduction of weight, right? Because increase in weight has the tendency to increase the weight of the aircraft. So before checking that stress analysis or the product will withstand, if we directly design and engage, it may lead to failure, right? So this 3D printing is the advantage. It will show the digital twin. Digital twin is nothing but before the execution of job, we can see how it is and we can see the performance also, how much the bearing load and the load it will stand, what will be the torque it will stand, everything we can see in that. And moving forward, the next is a robot. What is robot? What is robot and cobot? Can someone clarify? The difference between robot and cobot? robot, how many axes the robot will have? Number of axes. For example, let us take one example. I am using one application. I ask you to develop just a pick and place. How many axes we require? Just for picking and placing in one place to another. We require 3 axes, right? The gripper will hold from one axis and it will move up and it will move to the other end and it will put it down. So moving up is one axis, moving left is one axis, and dropping down is one axis. 3 axis robot is required. And whereas in 6 axis robot, you might have seen 6 axis robot is having combination of 6 servo motor and 6 servo drives, and which will be algorithm or programmed in such a way that motion should be in linear or in transverse or angular, so that the reach should be an advantage. What is the difference between the cobot and robot? Okay, I'll take you forward. Robot is nothing but which will work as per the command. For example, the program with the pendant. I think you might have seen the robot, right? Robot and pendants and all. The program will be in such a way we can teach the position where the robot should reach and what operation should perform. The application of robots is in welding it is, or in painting it is, or wherever it is. So the reach is the main concern of robot. So if it will work as per instruction is given, it will not consider any safety. Suppose if any safety is bypassed and if people are inside working along the robot, it will not see the person. It is directly crash and some fatal incidents may occur. So robot will not see anything until the safety interlocks is there. If your safety interlock is bypassed, it may lead to a big accident. The cobot is nothing but it's human interfacing. It will work along with us. Like one arm of the cobot will be picking and placing on the table, and whereas we can work. We can stop the cobot by hand. It is not such robot. Based on the feedback, it will stop. There is a stress bearing load can be programmed in such a way beyond the such stress, the cobot will stop automatically and it will resume from the same position itself. So what is servo drive servo motor? Servo drive servo motor will be in the cobot. For example, 6-axis robots will have 6 servo drive and 6 servo motor and encoder. Encoder is nothing but the position of that robot has to be monitored, right? That will be monitored by the encoder. It will show at what position it was, and servo drive is nothing but giving the command to the servo motor. Servo motor will form the compilation from the servo drive so that it will reach the axis as per the command has been given. You know what is the linear motion and angle motion, right? Linear motion is the travel from x-axis or y-axis in a straight way. Angular motion is for the rotation. So you got to know about robots and cobots. It's a different session. In robot session itself will take in detail. If you go into it, it will take minimum on 20 to 30 hours of slide presentations. And cobots is shortly 4 to 5 hours of slides presentations. And going forward, and applications of robots, you might have seen cobots and robots application. Cobots is collaborative robots, automated system powered by AI. And in the digital twins, as I told you, before the production of job itself, you can see what how the job will be look like. And basically using real-time data and from IoT sensors. IoT sensors is nothing but the data fetching from the missions. For example, let us take in the field of maintenance, and I'll let you know in detail. My screen is visible, right? I think something has got stuck. Just a moment. Able to see my screen, right?
Yes, sir. Yes, sir. It is visible.
Sure, thank you. So why AI into the industry? Why we require AI into the industry? Because you have human intelligence. Why we require AI into the industry? You can be interactive, like it's an interactive session only. Okay, I'll let you know. Yeah. Suppose in human compilation, there will be errors, right? For example, the data fed from the machines will not be accurate. Suppose based on the productivity from the machine, if someone has to monitor what are the count the person is saying, whether it is correct or not, we have to be entering into the Excel. But whereas in AI, we can directly fetch from the mission automation from the PLC itself, the how many job he has produced. And based on that, we can take up into the our ERP software, and based on that, we can move to the next process. Like each and every stage of production will have the job curve, right? It is a manual movement. So manual movement is the tendency as to create human errors. And whereas in AI, everything will be interacted in hand, and it will be incorporated with the industrial automation, so that the interaction with the digital automation, in the sense the fetching of the data from the machines directly and compilation in the form of reports, so that you can have the real-time analytics and vision. And one more important thing in AI is detection of the products. Like the product is manufactured, the manufactured product has to be recognized it is good or bad, right? For that, what we need to do? We need to compare with a good product. So that has to be will be taken by the high-end vision cameras. And based on that, it will compare the existing. Whatever it teach, it will do. For example, if it teach the bad product as good, also it will do. The advantage of that high precision cameras, it will respond in fraction of seconds. We can imagine the scanning time is hardly 0.5 seconds. And core pillar in manufacturing, you know about the types of maintenance, right? What are the types of maintenance? Since you all from the mechanical background, you might have known what is maintenance in manufacturing. Maintenance are of three types: breakdown or reactive. Suppose if the machine stops due to some issues, that responsibility information will be given by the operator. The operator will be creating from breakdown slips, or he will give the information tag through the system that machine is stopped for such a reason. So the maintenance person will come and attend, and he will recognize what kind of the breakdown. Suppose if it is sensor failure, or it is a PLC output failure, or it's a valve failure, whatever it is, he will change and he will restore the breakdown, and the hours you will mention manually. Like the breakdown hours will be mentioned manually. Whereas in AI, the compilation will be in such a form that mission stop itself will be automatically logged. Like the mission stop for more than 1 minute, the data, irrespective of the reasons, the data capture will start happening. While the operator claims to stop the mission intentionally, that also will be mapped, so that there is no production hours. Like that, we can simulate in AI. Suppose if mission stop due to maintenance, the trigger will be to the maintenance department automatically, and the person comes and attend. What is the time duration is taken and what activities he has done, everything can be fed into the system. Through tab itself we can feed, and that final compilation and root cause analysis also can be done. So one is in terms of in kind of breakdown maintenance or reactive maintenance, that is what after the breakdown is happening. And the second is preventive and predictive. Can someone state what is preventive or predictive maintenance? Preventive maintenance is based on the calendar, right? Irrespective, like how you will be carrying out the preventive maintenance for our DG's compressors, whether it is running or not, after 30 days or so after certain hours, we'll be changing the filters or oils, like similar to our car. If it runs for 10,000 kilometers or 3 months, whatever it's earlier, we'll take it to the further service, right? That is preventive maintenance. Predictive maintenance will be based on the time and condition. Conditional based maintenance or time based maintenance will be the predictive. So let us assume the machine is running continuously. We need to monitor the life of the machine, right? So each and every product is having a life cycle, right? For example, a valve will have number of actuations, a cylinder will have number of strokes, a motor will have number of running hours. Beyond that, it cannot function without proper maintenance. So main intention is the data capturing. For example, the machine is running continuously for 360 days. We have to compile in form of bifurcate in form of 12 months, right? In 12 months, we need to make a predictive maintenance or preventive maintenance based on the machine running hours. If machine is not at all running, so based on the running hours only, we have to make this predictive maintenance, right? So the data capture from the machine on time will be done automatically in the AI system. So that based on the running hours, the machine AI will give a command, stop, you require a maintenance, so that after that maintenance, it will resume functioning. That is in usage of AI in predictive and preventive maintenance. And real-time applications of AI, you might have seen daily will be using like Siri, Alexa, Google Assistant, and other prominent examples is autonomous vehicles equipped with AI for navigation and safety. Like India, it's not true, but you can see in Europe and all, it is already established that without drivers or without autopilots, everything is running, right? That is purely based on the AI commands, right? And now in advanced robotics also we are using in manufacturing, whereas the commanding will be taken up by the AI through robots. And in medical, in surgery also people started using. And let us go into the industrial automation topic. Industrial automation is the control system based on the feedback from the sensors or processor or operator maybe. It's based on the feedback from the sensors or limit switch, and the command will be to the machine. Like any kind of machine, you require inputs, right? Input and outputs. Based on that, we can get the product. For example, let us assume a sugarcane crushing machine. The input is from the motor. It should rotate and should crush. So the output is the extract of the sugarcane juice. For that, we need to make the crush increase step by step. In the first level, the crush will not be that much, but we have to gradually increase the crush. That can be done in the automated system nowadays. It's a simple example. Analogy I'm telling to explain. But whereas any kind of industrial automation or machine requires that PLC or SCADA. PLC is nothing but programmable logic controls. SCADA is nothing but prior to AI, we used the SCADA, supervisory control and data acquisition. It is the continuous monitoring of the temperature. With respect to quality, we can take it out. With continuous monitoring of temperature, pressure. Even if the slight reduction of temperature may impact on the products, right? Wherever they require high accuracy, those areas people may implement SCADA. And in CNC controller, you know the numeric controller is nothing but the binaries, zeros and ones. And apart from that, IoTs can be used in energy management system also. For example, let us assume a particular department or particular cell. Like that particular cell for turnover of 1 crore, they can use energy of let us say 10,000 kilowatt hours. That mission capability, the mission will consume 10,000 kilowatt hour for generating 1 crore of product. But suddenly, if you want to know what happened if it is crossing instead of 10,000 kilowatt, if it go for 12,000 kilowatt for the same, we can fetch from the energy management system, IoT system, like which particular mission or which particular operation has cost the higher energy. And there we can work on it so that it will be useful for that reduction of energy and consumption also. Like in AHS also, in initial design, normal conventional CFM is achieved by the induction motors with the impeller design. Now it is upgraded with the DC fans. DC fans is nothing but EC fans electrically commuted, whereas the AC supply will be converted to the DC supply, and the same thrust with 30 to 40% of efficiency is attained on EC fans. And AI in power station, can this real-time example, like in daily basis we are seeing in our home also, like a huge generator system, like we have the power distribution across to our entire city, industry and homes also, right? What will happen is suddenly one zone is switched off. Like let us assume there are 3 districts. If one district is switched off, what will happen? All the loads to the generating station, it will have a kickback load, right? It will trip the entire system. So load control system, advantages of load control center is to monitor the loads across the different sections, and it will give the command to the generating station. It will be based on the command feedback from the load generation to the generating station, that you should generate this much. Like the command should be either to the turbine which is generating, either to the wind turbine which is converting the air kinematics into the electrical energy, or can be to the solar or any thermal power stations, right? So how it will come to know? Like people will not give the command orally. I am shutting off this station. You please decrease the generation. I am increasing this station. You please increase the demand. It's not a oral command. How it is functions? Okay, I'll move forward. Whenever there is an increase or decrease in load, the frequency will get proportionally increased or decreased. For example, if the generation station has the increase in frequency, it means the sum of the load station has got a load shed or tripped or power failure. So that based on that, the generation areas, RPM of the turbines or RPM of the generations, thermal power stations, and shut off of solar stations will happen automatically. It's nothing manual. Even we cannot control manually. Initial stages, it has been manual condition. Now AI has a bigger play in power station and power generation sections also. And moving forward, as I told earlier, the predictive maintenance, downtime reduction, maintenance cost reduction, overall productivity increase can be attained by AI. And once again, I like to take you to this digital manufacturing and robots. So you got to know what is 3D printers, right? 3D printers is nothing but converting the pixels in 3D form. What is the pixels in 3D form? Can someone say? In 2D, it's pixels. In 3D?
Sir, can you repeat the question? What is
the pixels in 3D form?
What is the pixel?
Yeah, like in 2D, we are converting into pixels, right? Like 2K, 3K, 6K in 3D form?
No, sir, I don't know.
Okay, it's a form of cubicles.
Okay, sir.
So the slicing will happen in a triangle way, so that after the slicing, the 3D printing will take up. Just a moment. My screen is visible, right? Someone has lost the slides. So my screen is visible, right?
Yes, sir. Yes, sir.
Sure.
Industrial automation slide is going on, sir.
Okay, just a moment.
Now predictive maintenance.
Yeah, sure. Thanks. So the important concepts that we are going is 3D manufacturing. Since everyone is the mechanical background, the customer will suggest you to develop a product for real time. If you think to manufacture the product, it will take minimum 2 to 3 weeks. First, you have to create a rapid prototyping tool for that. Based on that, I mean, it's a prototyping tool is nothing but a temporary tool, which will not be used for the huge production. And based on the tool, you have to make machining and milling, grinding, whatever it is, to get the final product and show to the customer. It will take minimum, the sample product will take minimum 2 to 3 weeks sadly. But whereas in 3D printers, the advantage is we can develop the any product which is size completion of the 300 by 300 also within a span of 16 to 24 hours. Not more than that. Any product, even with the inclined angle also, we can develop in 16 to 24 hours. I can share some 3D printing slides separately. And finally, the AI necessity. AI necessity is for the competitive necessity for the cost reduction and efficiency gains and sustainability. Again, to the basics. What makes an AI? You got to know, right? The binaries. Like initially, can you imagine what is the size of 128 megabyte hard disk? Tentative. Now, which is we are having in almost up to 512 GB or 1 TB memory card in our packet, right?
Yes,
Can
sir.
you imagine the size of 128 MB hard disk?
Initially, sir. Initially.
Yeah. Yes.
I think the size of drum, 200 liters. I think.
It is almost the size of room. It's
Wow.
almost 4 meter by 4 meter.
Wow.
And at that time, the cost also is around 80,000 USDs.
Yes, sir.
In 1985,
Yes, sir.
the memory storage device now compared to the analogy, we are the richest people. We are having crores compared to the 1985. We have crores and crores in our packets,
Yes,
right?
sir. Yes, sir.
And apart from that, whatever we are giving the command to the AI, we'll get the feedback. What surprise the AI, right? Can someone say what will surprise AI? What algorithm is not written in AI? Everyone using voice recognition, right? Voice recognition, Alexa, Siri.
Yes, sir.
Sure. Moving forward. Actually, I didn't know that slides is somewhat missed out about the 3D manufacturing, but you can Google it out. There are various technologies in 3D printing like vat polymerization, that filament extrusion or powder bed fusion. There are various technologies and now they are introducing AI also into 3D manufacturing. Whereas it's just heating and melting the jobs and joining as small droplets. But now the robots has come into action, whereas it is compiling the 3D images. Now 3D printers itself as a 3D images, instead of layer by layer, it will access unique areas of the part and it will make. That means any 3D printing we require the support structures, right? It cannot hang in overall. But whereas with that AI and advanced robotic interfacing, the printing can be interfaced with the robots. You can Google it out. In YouTube, you will get everything.
Yes, sir.
Okay. Moving forward, I think I clarified to that best of industrial things, and I like to have a questionnaire sessions. Whatever you like to question and whatever you like to get clarified, please let me know.
Okay. So I am Professor Brijbhushan Shukla. So all participants, I like to request you all that you can ask questions to Mr. K. Sridhar. He is open to questionnaire. So everyone, you are open to questions. So kindly ask your queries, doubt, questions to Mr. K. Sridhar.
It's an interactive session, right? You are spending your time or putting your efforts to learn something new or some advanced what you comparatively from the existing. It's a interactive session. Like I can learn from you or you can learn from me. It's like, but don't think me as a ChatGPT that I can answer anything or everything. But I can clarify to the best of my knowledge, whichever I know.
Sir, I wanted to ask one question.
Please.
Sir, can we manufacture engine component, for example, a piston from
Yeah.
CNC machine, but by integrating AI in CNC software? I mean, if I put just dimensions required for piston, so can the
Okay.
AI do all the coding work for me in CNC machine, in CNC software, and manufacture a piston? For example, the coolant on, off, chamfering, milling, drilling. Can the AI do all the coding?
It will not do automatically, but one time if you teach anything, like if you teach for the first time, it will grasp and it will automatically. But if you set the rules, it will execute. Let us assume
Okay. So if
that is here I go. Chess.
yes, yes.
Yeah. What happened? There is a rules like how the pawn moves, how the king moves, how the queen moves, right? So if you set the rule in AI, you can compete with it. Even for example, the number one player like Vishwanath Anand, Gugesh, or Bharat, or Carlos, whoever it is, they can't beat the system because the rules, what the human has been defined, that has been taken to the perfection by the system, and the system is the capability to overlap humans. Like human has the tendency to think for 200 to 300 steps, for example, but whereas the system will compile 500 to 600 steps. For example, the same pistons, what you are trying through manufacturing the CNC, right? If you compile with the programming for the first time, the next time you no need to do it again.
Sir,
It
if I, sir, okay, next time the software will do by itself. But if
Yes.
I change the dimensions, let us say I want a bigger piston for a truck. So can the AI manufacture the whole piston, required piston?
Yeah, it's nothing but the scaling, right? It will take up automatically.
Okay.
And one advantage is I like to inform this 3D printer, what I told, it's not only in manufacturing of that polymer products. Now it is have an advanced system, whereas it is have the tendency or capability to melt metals also. You can get any metal products like pistons also, you can manufacture into the 3D printer. Just you can create a CAD file like how you are machining. It's separative technology is from the machining, milling, grinding, coolant, that huge process, and it's requires time, accuracy, precision, everything. But whereas you can get the drawing directly from the customer for the piston, or else you can design directly a piston. It's one advantage in additive technology compared to separative technology is you don't need to worry about the accuracy, because it will be developed step by step. I mean, layer by layer, micron by micron. Even for metal also it is possible. You can develop a piston, a alloy wheel, um, a crankshafts, a walls, whatever it may be. In manufacturing, in metal, also now it has an advanced technology. The only thing is the melting point has to be taken care.
Okay. Okay, sir.
And into the automation, for example, the numeric controls, what you are telling, right? What is numeric controls? The CAD file what you are creating will be converted into the G codes and M codes, right?
Yes, sir. Yeah, G codes and M codes.
Yeah, the machine will understand only the G code and code. It will not because it's a kind of binaries. G code and code is nothing but a binaries.
Binary, zeros and ones.
Yeah, ultimately.
Yes,
So
sir.
if you want any modification in particular portion of that, we'll directly modify the G codes and N codes. So that's what I try to inform in the first phase. The zeros and ones is the main thing. For example, how we are interacting. I'm speaking both video as well as voice. How we are receiving everything in form of zeros and ones. But it's an instant. You are not given. It is in very instant, right? It is not even a fraction of second. If I speak, you can listen in a fraction of second. So the interim process, what and all happening is that it will convert my voice and my video, whatever it is, in the form of binaries. It will capture, the camera will capture and process it in form of zeros and ones, and it will take my voice and it will complex and it will make a mixture of video and audio in the format of zeros and ones. And it will be compiling in the system and it will make a data transfer from my end to your end. And again, it will form the same compilation of zeros and ones into the voice and transmission of signals.
Yes, sir. Yes.
So instantly we can able to interact without any time consumption.
And sir, my next question is, are the industries, mechanical industries especially, are they
Yeah.
using AI in their manufacturing, for example, CNCs, VMCs? Are they utilizing AI for manufacturing?
Yeah, actually, to be frank, AI in form of IoT they are replacing.
Okay.
Like Internet of Things, right? Initially, for example, there are, let us take the printing industry itself. Printing industries or battery manufacturing industries.
Yes.
There are almost 20 to 35 processes involved in between to form a final product.
Yes, sir.
Each and every product will require a manual transition of data. For example, one battery, if you try to manufacture, it will follow steps of 14 steps. First, you need to create a grid, and again you need to cure, and again you need to make a pasting of lead oxide into it, and again you need to cure, and again you need to make a burning process and assembly and acid dipping, and finally testing, and then finally into the sales. Testing itself is a PDA line they will call product development. The testing itself will have high voltage testing, short circuit testing, everything. So everything, the data movement, like one battery you can understand, but in terms of 1 lakh batteries,
Yes, sir.
imagine the data transfer is not as easy as we think. So automatic fetching of data is required. So like in an hour, how many grids is produced, and how many grids is required for form one pasting assembly. How many pasting assembly is required to form one battery assembly. Like we need to create a positive as well as negative, right? Positive and negative should not mix. If it mixes, the entire battery will fail.
Okay.
So that cautiousness also has to be taken care in form of IoT. Whereas in artificial intelligence is just used for the purpose of compilations, not for directly into the manufacturing.
Okay.
And whereas if you consider the printing industry, for example, you can see some of the icons in your card dials, right? It's just you can see 2 to 3 colors ultimately.
Yes, sir.
But it requires the printing of 14 colors really in real time, both forward as well as reverse direction. 14 colors means the sheet has to be passed for the first time through the printer. I mean, printing is a screen printing. The ink will be deposited on the screen and it will be cured into the dryer, and again the same sheet for the next color. Again the same sheet for the third color. Like that, it will be passed for the 14 times and finally into the baking oven. And after that, it will be following the post-coating activities like cutting, trimming, and above that, it will be following the lamination activity. So almost the 20 processes is involved for developing a one sheet of product. Whereas in 3D forming, you might have seen now, initially we have the flat dial. Nowadays, we are having the inclined dial, right?
Yes, sir.
Like embossed. For that, we require forming operations also additional. The printing will overlap on the forming, and then it will move. So additional another 2 stages of process has been incorporated into it. So what happened? It will not be in single pieces. It will be in lakh pieces. Like 1 lakh pieces has to be printed. For that, huge compilation of manual is required. Manual intervention is required. But after the intervention of this AI, this IoT concept, like mission data capturing, I told, right? So the printed sheet will be automatically captured and it will be in the system format. Like first color, 450 jobs has been printed. 450 jobs, in 450 jobs, 4 dials will come. So ultimately 1800 jobs, 1800 dials, first color has been printed. So again, second color has to be moved. In second color, how many jobs is printed, how many is left out? Like compilation and what process and what is the lead time for the next process. And after that, all stages are completed, it will be automatically moved to the ERP system. Without that stock transfer, you might have heard about the ERP system, right? That once the product is manufactured, it moves as into stock. Then when the invoicing is possible, like raw material into product into final product, FG goods, and FG goods to invoice. After the invoice, finally, it will be tracking for the payment. The conversion required a huge conversions, which can be tracked through IoT system, Internet of Things, data fetching and compilation.
Yes, sir, yes. Yes, anyone, any questions? Participants, are there any questions among you? Questions, doubts? You can ask to Mr. Sridhar, sir. Participants, any questions from your side? Okay. Okay. Sir, one last question from my side.
Tell me, sir.
So, sir, previously, let us say, for example, 10 years before, from 2015, from 2010, many robots were installed in companies.
Yes.
So, robotics were used, sir. And nowadays also, we have taken industrial visits of our students, and we have seen for robots, they
Yes.
were used in manufacturing. So,
Yeah.
is there AI sort of thing in robots, sir, from the 2005, 2010?
Yeah, actually, you can see the robot itself a composition of AI.
Okay, okay.
It's a combination of 6-axis servo motor, what I told, right?
Yes, sir, yes, sir.
To be frank, it will reduce human effects. The purpose of introducing robo is for simple app operations. If we invest robo just for pick and place, the 2-axis robo, what I told is nothing but pick and place operations. It will pick from one end and it will move and place on another end. For that, people will not use the 6-axis robots. 6-axis robot where we are able to make the reach. For example, let us assume the car body. Car body we need to be welded. Initially, human as welding. You just imagine 4 people welding the car body. For getting the output of one car body, it requires 2 hours of time. Can you imagine with the robotics? The same will be done by 4 robots.
Okay.
And so 4 robots will be programmed in such a way. Robotic program is very simple. Like we don't no need any algorithm. We can physically pull, if it is a cobot, by hand and teach to the location. And then we have to trigger the command like start building. It's nothing simple is while programming only. It's in Python, you might have seen. It's a basic programming. You can make the pendant move to the particular position and teach. This is the position 1. There we need to weld. Then the robot will start the ignition to the welding. And then it has to gradually move. In what way it has to move? Like the car body shops and all you might have seen. No, it is not linear. It will be curved and it will go under also. So the profile that can be created to the pendant, or else if we know the G codes and N codes, if the card design, if a manufacturer will have the card design right, the card design will be automatically fed into that system. So based on that, the robot will create a path on its own. Only the thing is we need to give the command, the welding, how much percentage of welding ignition you need to give. So advantages of robots is to reduce human effects and efficiency.
Okay, sir. Yes, sir. So, sir, what is the since we know AI since post-COVID, sir. So, what is the origin of AI? I mean, from which year AI has been started?
Sorry.
We have seen the advent of AI post-COVID, sir. So, can you inform us when the advent of AI?
Sir, of AI.
Since robotics came in
You can able to hear my voice, sir? Sir, your voice is not audible.
Sir, am I audible to you?
Yes, sir. Now it's clear. Yeah.
So my question is, sir, since when in India we have seen the advent of AI post-COVID, sir. So
Okay.
we knew about AI post-COVID. From 2020, we have hearing a lot of AI. So
Yes.
my question is, the origin of AI is from robotics, that is from 1960s.
Yeah. Actually, AI, to be frank, we should not take AI in a mistaken way. AI is nothing but artificial intelligence. Like we are creating an algorithm to do some programs.
Okay, sir.
Whereas the algorithm will be created by the computer.
Okay.
To do the program is AI. For example, human intervention, human effort is less. Like nowadays, we are using its share market and all, right?
Yes, sir.
Initially, we used to click, we used to sell when the prices go high. And when the price is low, we need to buy. But now, these activities is driven by AI, even in e-commerce. Like, for example, let us assume we are buying a product from Amazon. It's nothing like AI. We are just giving the buy command to the Amazon. There is a zero human intervention. Yes. That once if you proceed the buy command, that AI will compile and it will choose which particular vendors. It will show the list of vendors, which particular vendors you need to buy. And it will give the instruction command to the vendor directly to dispatch the item to the people. So AI is nothing but initially one set of algorithm is developed by human, and the advanced set of algorithm is developed by system itself. For example, let us assume one simple analogy, like we are creating one program manually in PLC. And now what we are doing, we are putting into the chat GPT. Chat GPT is working for us, or Perplexity is working for us, and it's creating a program in simple way. For example, initially we used to make a program for about 20 to 30 lines for simple operation of pick and place.
Yes, sir.
Now, if I put into the chat GPT, it is working on while putting into chat GPT, no human is working. The robo or AI is working for us, and within a line of 4 or 5 line items itself, we can achieve the same output. We can get anything in AI. For example, in real-time applications, in PLC, SCADA, for example, PLC programmer, initially, there are very least people. Hardly you can see in markets out of 1 lakh engineers, 10 to 12 engineers only will be available as a programmer. Now you can see abundance of people. That is due to the integrated technology of AI. I mean, the conceptual, you can see and learn everything by yourself. No need of some books or external people is required.
Okay, sir. Thank you, sir. So, our today's session has been concluded. So, thank you, Mr. K. Sridhar, sir, for giving us such a wonderful insight on the topic AI in digital manufacturing and industrial automation. On behalf of SJS Pratishthan's Chairman, Engineer Basavaraj Mangrule, sir, our CEO, Colonel Joy Daniel, sir, Principal of SJS College of Engineering and Technology, Dr. B.M. Patil, sir, Dean Academics, Dr. P.M. Ardhapurkar, sir, all HODs, teaching staff of SJS College of Engineering and Technology, and participants. I, Professor Brij Bhushan Shukla of Mechanical Engineering Department, thank you, sir. Thank you, Sridhar, sir, from the bottom of my heart.
Thank you, sir. Thank you very much. Nice meeting you.
So, participants, So today's session has been concluded, and the next session will start sharp at 1:30 p.m. And for next session, we have again an industrialist who have 28 years of industry experience. He is Mr. Nitin Kenjale, who is plant head, Pranit Engineering Works, Chikli, Pune. So 1:30 p.m. Mr. Nitin Kenjale will take the session. Thank you all. Thank you, sir. Thank you.
Bye.